Hi, my name is James Cullis. I'm a water resource engineer working for Aurecon in South Africa, and we've got over 80 years of experience in working in the water sector across Africa, and particularly interested in integrated water resource planning and increasingly how we integrate climate change into infrastructure planning, particularly related to water and sanitation across Africa. We're also part of the Future Resilient African Cities and Lands research team collaboration, which has been led by the University of Cape Town and is part of the Future Climates for Africa program. I'm sorry that I can't be there in person to join in your conversation, but I'm sure you'll have a really interesting discussion, and I look forward to hearing some of the outcomes for it. And please feel free to contact me if you have any further questions or follow-up comments. Basically, today I wanted to share with you some observations and experiences we've had through our work across Africa in integrating climate change into particularly water infrastructure sort of planning, operations, and design, but increasingly the findings we've come out of the Fractal research program and the FCFA program, which has led to some really insights into how we integrate climate change better and make informed decision making to support basically sustainable economic development across Africa in the WASH sector. Obviously, a lot of the talk in the climate change narrative is not just exposure to climate change risks, and a lot of the time we talk about how temperature is going to change or precipitation is going to change up, but what's really coming clearly is that just as important is the vulnerability side of it. And in some areas, changes in climate change will have very little impact and raise a risk. But in other areas that are highly vulnerable, even small changes in climate change can have significant impacts in terms of increasing risk. And that's particularly true for the water and sanitation sector in Africa. This is just some work done a couple of years ago from the ECRAI study, which gives you an idea of some of the climate change risks for the water sector across Africa. And you can see a number of major river basins where they've looked at the green dot being the kind of historic climate, and then the orange and blue dots being a range of the latest climate change scenarios for some of the older models, the CMIP 3 models, and then the newer ones, the orange ones for CMIP 5. And what you can see is that there's still a huge range of uncertainty in terms of what the future climates are. And even more disturbing, if you look at the difference between the blue and the orange dots, is that range of uncertainty seems to be increasing rather than decreasing. So typically in the infrastructure sector, we've been saying, well, there's too much uncertainty for climate change scenarios. Let's wait and see till the climate models get a little bit better, and then we can make more informed decisions. Given the chaotic nature and the huge challenges of these climate models, that uncertainty doesn't seem to be narrowing. If anything, it seems to be getting greater. And so we have to adapt our decision-making process to get used to a level of uncertainty and ambiguity going forward, rather than being able to rely on perfect foresight. Some work that we did in South Africa was also recognizing the highly integrated nature of particularly water infrastructure and bulk infrastructure. A country like South Africa, for example, has a large number of big dams, interbasin transfers, highly developed planning process for bulk infrastructure, large system models like the VAL, for example, moving water all the way from Lesotho through to Gauteng and from Tugela across. And even in Cape Town, the Western Cape, we move water across boundaries. And we looked at a whole range of climate scenarios using a hybrid frequency distribution approach of multiple climate models in conjunction with the guys in MIT. And what we found was on, for example, on the left-hand side, the range, this sort of shows a frequency plot of the range of climate change impacts on surface water runoff to the whole country. And you can see obviously a big wide range of impacts from sort of minus 10% to plus 40 or 50% increase in runoff, and quite significant differences between two future climate scenarios, the unconstrained emission scenario and the level 1 stabilization, not so much in the mean, but certainly in terms of the extremes. And that's one of the considerations to make when looking at climate scenarios, is to say, well, it's not so much what happens in the average, but what happens at the extremes, and how do you remove those risks, and mitigation is obviously one of them. But in the figure on the right shows that when we modeled this all in terms of water supply, recognizing that we can move water all over the place and and to different sources, that range of impact narrows quite significantly because of the sort of mitigating impact of having an integrated planning system and bulk water transfer system. And so it shows how important these are, and again, similar to the Blantyre example of having a diversified sources and be able to draw from different basins in different parts of the country. But even more, you would have, if you added into their alternative sources like balancing of groundwater and surface water, and now we're looking at desalination and reuse, rainwater harvesting, all those other sources, how you start to narrow your risk associated with the uncertainty of climate change. And so again, it just reinforces the importance of good planning and integrated thinking when it comes to water and sanitation. So coming to the Fractal study, so Fractal is as you see, it's a large consortium of other organizations led by UCT, and it's really a very strongly bottom-up driven process. It's really all about co-discovery, exploring with actual decision makers in a number of target cities. They've actually got embedded researchers in there, and one or two of the other speakers will talk a little bit more about the approach they use to not only bring scientific expertise into the space, but really to have scientists and experts sit there and listen to what the challenges are for the real decision makers on the ground. And it's really through an iterative transdisciplinary kind of process of co-exploration that we can start to unpack where the real climate change risks are, and how we can start to influence decision making, particularly in the water and sanitation sector. The joy of Fractal is it's very cities focused. Typically a lot of climate change studies, particularly in the water space, tend to look at the big basin and how it all integrates, whereas Fractal, we really start with the city and the people in the city as a center, and then start to work out from that to where the various climate change risks are and what sort of information would be useful to help decision making in that space. The main vehicle that we've been using is the City Learning Labs, which is a very interactive session, a range of stakeholders from city decision makers to scientists, to policy people, to NGOs, and to engineers, all kind of working together to unpack some of the key issues, what we call the sort of the burning issues, and then start to sort of investigate what the particular sensitivities are to these, how vulnerable they are to various climate change impacts, and ultimately where certain decisions are made, what is influencing these decisions, and how can the sort of scientists or others start to integrate more information to help in that decision-making process. For example, the bottom left is mapping out the Lusaka water supply to really understand it from a individual user perspective, building back up rather than from a large basin scale. And the top is a session in Windhoek where we're trying, identifying information on water infrastructure, climate resilient water infrastructure, obviously a critical aspect in the city of Windhoek. The use of climate narratives has certainly become something that's very strong, and it corresponds not only to Fractal study, but we found it also used in other projects where we're developing climate risk resilience plans. The use of detailed maps and highly technical information, while valuable to some people, is often hard to interpret and confusing, and doesn't really accentuate the risk or even get collaboration and buy-in. So we started using individual sort of user-based personas and individual stories to start to communicate and explore how particular climate change risk, whatever the science is saying, how that would influence people's daily lives. And that gets a lot more buy-in and traction and engagement in the process. One of the other things we're considering is a framework. So obviously we talk about climate information and climate knowledge into water infrastructure, but it's very much dependent on the type of infrastructure you're talking about or the problem you're trying to solve. And there's a very strong spatial and temporal framework to that, where some information is necessary at a daily or sub-daily level, at a small scale, city scale if it's stormwater modeling, more catchment scale if it's flood modeling. And then when you talk water resource planning, you need monthly, interannual timescales and over multiple catchments, and could be large areas, sort of big basins, and when we start to have interbasin transfers, even multiple basins. And we need to understand exactly what the decision-making process, what the specific spatial and temporal context is, to be able to start exploring where the relevant climate change information is appropriate. One of the examples coming out of Lusaka, where we've done a lot of work, really strong bottom-up process, a lot of exploration, and then we started to build it up out towards whatever the main sources are, and then looked at the various vulnerabilities of those. And one of the big things you realize, particularly for African cities, is only a relatively small proportion of the population has their water supply through a formal system. And many climate change studies, particularly in more developing worlds, will look at the impact of climate change on these formal systems. Whereas if you want to get an overall picture of the pure vulnerability, you need to actually look at all the water source options, which would include local groundwater options, kiosks, harvesting, all those sort of aspects. And then we unpack it back towards the primary source. And for example, what we found in Lusaka is when we started to unpack that, you realize the formal water supply system wasn't necessarily particularly vulnerable. It obviously came from the Kafue River, but it was a relatively small volume of water that was being needed to supply Lusaka. And so from a pure water supply point of view, there could be quite significant variations due to climate change of the flow in the Kafue, but it wouldn't necessarily affect the availability of water directly, because it was still a small proportion of what was going through. But what it did affect was it would affect the hydropower generating potential in that basin quite significantly. And the hydropower was necessary to pump the water from the Kafue basin into Lusaka. So what you would find is that, yes, the formal and water supply system to Lusaka was particularly sensitive to climate variability in the Kafue basin, but not necessarily through the direct water availability, but through the availability of hydropower to pump the water. And so that helped to unpack these limits, and then also start to look at other alternatives where the real vulnerability was people who were dependent on not on the formal system, but utilizing shallow groundwater or small kiosks. And actually part of the sort of adaptation recommendations was to actually get more people onto the formal system, but then needing to address the energy constraints and maybe consider alternative energy supply options to make that more reliable. We're now looking at a bit more study, further extending the study to look at the overall impact in the Kafue, where we bring in the hydropower, energy risks, and also the food aspect of it, because obviously a lot of water is used to generate food in the basin, which also is linked to the city from a job creation and a food source aspect. So we are now expanding our decision scaling approach to take that into consideration, and hopefully we'll report on that on later. So that's all what I want to say for today, and so thank you for listening, and I hope that you have a very interesting conversation, and I look forward to hearing more about it at the end. Thank you very much.